Hope all of you can see the PowerPoint presentation in my laptop. Is it no? The PowerPoint presentation is visible from your side.
Yes, sir.
Okay. In our last class, we have discussed regarding the major drawbacks of the conventional file systems and with the application programs. Whatever the database actually used in earlier days, and to overcome such drawbacks, uh, the database management systems are actually evolved. Uh, the the uh, database management system is a collection of interrelated files and set of programs. That what is the role of that program? The program allow the user to access the and as well as the modify the files. The major, I mean, just a minute. The major purpose of such database system is to provide the user with an abstract view. Provide the user with an abstract view of the data. That is, abstract view means actually it will be clear more later. That is the system actually. Abstract means actually the system actually hides certain details. Means how the data actually stored inside the memory, or maybe inside the memory, or how actually data actually maintained, or how the data can be retrieved efficiently, or how actually the relationships actually exist among the data, or how actually represent that. So, so this actually leads to the design of a complex data structure uh, for representation of the data in the database. Okay, that is whatever actually I told. The main purpose or main role of the database management system is to provide the user with an abstract view of the data. That is, system actually hides certain details of how the data is stored and maintained, but such data can easily and efficiently retrieve from the database, and also the uh, uh, also hide the details of sometimes actually details of uh, uh, how relationships among the data elements are maintained. So because that most of the database systems users, those are actually users are not computer trained. Special training is there. Maybe the small training will be there sometimes. The complexity, this complexity is actually hidden from the user to a different level of abstractions, different levels of abstractions. So, so this, what are the different level of this abstraction? The physical level, conceptual or logical level, and view level abstraction. Is it clear? The, the certain details actually, how actually hide in a three different level: physical level of abstraction, logical level abstraction, and view level abstraction. In physical level, the physical level is concerned mainly uh, how the data are actually stored in the memory. That is, physical level, this is the lowest level of abstraction, and that describe or mainly concerned about the how the data are actually stored. That is, this physical level does not border what data actually stored. The physical level concerned the how the data are actually stored inside the memory, and here actually complex low level data structures are used. Next level is the conceptual level. Conceptual level, basically this actually describe what data are actually stored in the database. That is how the data actually stored, that mainly concern the physical level. What data are actually stored in the database, that described by the conceptual or logical level, and as well as the relationships that exist among the data elements stored in the database. Suppose some data related to customer and some data related to account and balance. How actually relate this to different type of information? That is, of course, customer having account, na? So this to different type of data need to be related, and that things actually described in the logical level. And in this level, the database is described in terms of small number of relatively simple structure, though this simple structure at the conceptual level may involve a complex physical level in implementation or physical level structure, and the user in the conceptual level need not aware of the physical level complex structure, such complex structure. They can aware only in the logical level what type of data actually stored and the relationship that exists among such data. And this level normally is used by the database administrator. Okay, database administrator actually use the logical level or conceptual level. Throughout our discussion later, actually mainly on the basis of the conceptual level and as well as the view level. So the DBA is the database administrator, use this level, who must decide what information is to be kept in the database. And also the DBA, there are several roles are there, we can discuss in the next class what are the different roles. Means he is the basically administrator of the database systems. So the which particular user can see the whole database, or this particular or set of users or subset of the users can see only the part of the database. Now question is which part actually you can see by this set of or subset of users. That can be decided by the database administrator. So later actually we can discuss about the database administrator. Next level is the view level, that is the physical level. Lower level is the physical level, then above conceptual or logical level, and top level is the view level. That is, this is the highest level of abstractions, which describe the only part of the entire database. Whatever actually I told just. Which part actually that can be decided by the database administrator in the conceptual level. But in the view level, users can see only the part of the database, not the whole database at all. And application programs hide the certain details of the data type here. That means the users of the view level does not concern or does not know the what type of data type actually used, or how actually stored, or what data actually stored, and how the relationships exist, such on. And I already told the view can also hide certain details, that is certain data or information. For example, the salary. Suppose the teller person in the bank, suppose in the banking system, the teller person can only see the information about the account or account holder. He or she does not eligible to see the what is the salary of a particular employee, or what is the salary of, or how much salary actually drawn by the branch manager. He or she is not eligible. Okay, that means this can for the security reason, certain details, that is the certain data or information, can hide from the specific users. And another point also, the single system can, that is the particular database systems, there many view is provides the many view, not only a single view, a many view is possible. Okay, so if we okay, whatever actually I told, is there any question? It's better actually I can discuss, draw the analogy with the data type in programming language. Suppose if we draw analogy, the concept in that with the data type in the programming language, that it will be more clear, uh, 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 more clear the about the distinction about a different level of abstractions. In most of all the programming language support the record type. Okay, for example, in C language, support the record such a way that is in a structure form. We can declare the structure by using the keyword struct. What is the, this is the name of the structure, and these are the, what is this, these are the member of the structure. Here what are the members are there? Name is the one of the member, four members are there: name, street, city, and phone number. Okay, that is, this actually can declare the one of the record. What type of record? Customer type of record, is it? Na, what type of record? Customer type of record. uh, if we consider, suppose, the banking system, not only the customer type of record, there are several other records are there. Other records may be, for example, the account type of record, account record. Okay, maybe the employee record, and so on. So in this example, say customer record is there, account record is there. In account record also contains some of the attributes. Say attribute, say account number, say attribute is the account, and say another attribute is the balance. Okay, similarly, employee, for simplicity purpose, employee name, not I am saying about the employee code, employee name and salary of the employee is there. Okay, that means the employee record actually consists of two fields: employee name and salary. Account record actually consists what? Two field: account number, balance. Customer record actually consists of four fields: name, customer name basically, street, city, and phone number. Okay, so now if we think about the physical level, this customer, account, employee, these records can be described as a block of consecutive storage location, block of consecutive memory location. Is it clear? That if we think about the physical level, that is, you can think like this one. The basically, the I already told, the physical level is the lower level, then view level, sorry, logical level or conceptual level, and then number of views are there. In the view level, multiple views are possible for a particular database. Okay. Now, for example, if we analogy with the data type in programming language, so in the data type, here the records, what are the records actually I have considered? The customer. Please tell me, customer. What are the other record I consider? Customer, account, and another one, loan, employee. Okay, these three records we have considered right now. That these records in the physical level, actually what these records are actually can be described here as a block of consecutive memory location. These records are described as a block of, because each record one block of memory is required, block of consecutive storage location. Is it clear? If we consider the array, then it needs a consecutive storage location. If we consider the link type of structure, then it may be not a non-contiguous location, depending on the physical part also. So now at the conceptual level, actually what happens? At the conceptual level, each record is described by the type definition. That is here actually record are described by a type definition. Sorry, this part of the device have some problem. By a type definition, that is, what is the type definition? Whatever actually I told, these are the type definition. Is it not? This is the type definition. This is a type this is a type definition. So, this is a type definition. That is, this is a customer type of record. This is a account type of record. This is a employee type of record. Okay. That is, in the logical level, we can think like the records are actually described by a type definition, and as well as I already told in the conceptual level also responsible or describe the relationships among the data. That is, and the interrelationship interrelationships among this record type. Whatever defined here. Defined means in a logical level it is defined. Na? That is, the records are actually described by a type definition, and the interrelationships among these record types is defined here. Okay. And what is the view level? I think in the view level, several views of the database are actually defined. Only the part, whatever actually I told, only the part of the database actually can see by the particular users. They cannot access the all the data stored in the database. Okay. Suppose view 1 can access the, say this is a teller person, say view 1. Here users are the teller person. So teller person can only see the information about the customer account. Okay, information about the this actually see the only the information about the customer account. Only access info about say customer accounts. Okay, say this is a I mean one of the tellers. Okay, suppose here payroll personnel is there. So payroll personnel cannot see the or access the data related to the balance or account holder. The payroll personnel can see only the what? Only the data related to the customer of, or employee of that, sorry, not a customer, employee of that bank. So is there any confusion?
No, sir. No, sir. No confusion. So no confusion, sir. You're audible, sir.
Please pardon me.
Sir, you're audible, sir.
Okay, I think there is any question means I
No,
try
sir.
to explain this one with a some record type of data type. We can draw the analogy, the different level of abstractions in database system, how actually level of abstractions actually maintain physical level, logical level, and view level. In summary, we can say the physical level actually, what actually physical level actually stored? Physical level actually concerned the how the data are actually stored in the memory. Okay, and logical level is the concerned about the what data are actually stored and how the relationships exist among these data. This actually mainly described in the logical level, and view level only the part of the database can access by a particular view, not whole the database. Okay, so the next one is the uh, instance and schema. What is schema? Schema is the overall design or structure of the database. Overall design or structure of the database. So, for example, the database actually consists the information about a set of customers and accounts and the relationship between them. So, schema is the basically the this is the design process. Whatever actually I told just before that, that is the in the conceptual level. There is basically some structure is there. Okay, uh, and here actually the schema normally divide into two type: physical schema and logical schema. In physical schema, database design at the physical level, and logical schema database design or structure actually design at the logical or conceptual level. Okay, and the schema or structure of the particular database, maybe the banking database system or maybe the I mean university database system or whatever, the schema or basic structure are change infrequently, not change infrequently. Okay, but rather than in instance actually, okay, before what is instance? Instance is the collection of information stored in the database at a particular instant of a particular moment of time. That is at a particular point, what information stored in the database, it's called the instances of the instance of the database. Okay, is it clear? The instance of the database means at a particular moment or at a particular instance, the collection of information stored in a database is known as the instance of database. The actual content of the database at a particular point of time. If we consider the similar to the previous example, that is variable, that is variable and as well as the type, with type are describing where in the logical schema. That is customer, structure of customer, struct customers, so on, or maybe the int char name 30. That is, these are the declaration, define the data type or record type. These are change very rarely, but the value of the variable can change frequently. So value of the variable is the instance, that is the, at a particular instance of time, what value actually contained by the particular variable. But the definition of the variable with the type, that is in the logical schema. And what is the physical schema there? That is the when the data, this variable or this type actually stored in the physical memory or concerned through the physical storage device that needs a single memory location or maybe a block of memory location. Okay, is there any question? What is the schema and instance at as a brief? Is it clear? Na? Schema is the overall structure of the database. That is some sort of, you can think like a uh, I mean suppose the university system. In university systems, the employee tables are there. student tables are there. Similarly, in the banking system, there maybe the customer table is there. Table means I mean the file, you can think like a, or relation, you can think like a, whatever. That in a relational database, actually the tables called actually tables. The tables, customer table, account table that contain the account number and balance amount, loan table that contain the loan number and loan amount, and maybe some other information also. Maybe uh, depositor table, which consists the account number and as well as the customer ID or customer number name. That is, this depositor table basically relate the another two table, customer and account table. That one we can discuss later actually in details when we talk about the normalization chapter, or maybe when we talk about the design of the relational database. So these are the actually structure. Okay, but instance is the at a particular moment of time how many or what records or what information actually what information stored in the customer table, that is the instance of the banking database. That is a particular moment of time, what are the content of the banking database systems, that is what are the content or what information stored in different tables of the banking database systems at a particular moment of time. This is called the instance of the banking database systems. Hope it is clear, or any confusion? Yes or no?
Yes, sir, it's clear.
Okay. Now I want to talk about the data independence. So what is data independence? Data independence is the ability or capability to modify a schema definition in one level without affecting the schema in the next higher level. What are the three levels of abstraction I told? The physical level is the lower level. Then what is the next level? Next level is the logical or conceptual level. Then higher level is the view level. Is it na? Higher level is the view level. So data independence is the ability to modify the schema definition in one level without affecting a schema in the next higher level. That is, suppose we want to change the physical level schema without affecting the schema in the logical or conceptual level, is called the data independence. Okay, there are of course the two type of data independence: physical data independence and logical data independence. Physical data independence means it is the ability or capability to modify the physical schema or physical structure without affecting the application program to be rewritten. This is not possible in case of conventional file system and application program. Whatever actually I told in my yesterday class. If we modify, then their application program also some need to be modified. But here actually this, if we maintain the physical data independence, then it have the ability to modify the physical schema without causing or without rewriting the already existing application programs. Okay. Similarly, logical data independence means is the ability to modify the conceptual schema without changing the application program or without rewritten the existing application program. Okay. So this modification at the logical level is necessary whenever the logical structure of the database is changed. For example, if we want to add some new table in the existing database, depending on the need, we want to store some new kind of information. So there may be chance to add in one of the table, and when we, that means it change the conceptual schema because the earlier table and include the new table. But when we add the new table, at that time the existing application program no need to be changed. Okay. And in general, the logical data independence is more difficult to achieve than the physical data independence, because the application programs application programs are heavily dependent or highly dependent on the logical structure of the data they access. Okay, up to that, any confusion? What is data independence? What is the physical data independence? What is logical data independence? Is clear?
Yes, sir.
Now we want to talk about the data models, uh, but it is a long portion. So, what is the data model? The structure of a database is the concept of data model. That is, by using the data models, you can say about the structure. That is, the data model is the collection of tools for describing the data, relationships among the data. That is, for describing tools for describing the data, relationships among or with the data, data semantics, and data consistency constant. If there is any constant is there, that can be the data model is the collection of tools. For what purpose? To describe the data, to represent the or to describe the relationships among the data, maintain the data semantics, and maintain the data or define the data consistency constant. Okay, and data model actually basically provide a way to describe the design of a database at the physical level, logical level, and as well as the view level. This is the important one. That is, the data model can be classified into uh, this category, following category. That is the record-based logical model, object-based logical model, semi-structured data model, and physical data model. So basically, physical data model, the name is clear. That can be used in the to represent the physical schema. And record-based logical model, there are actually three category or three types are there: relational data model, network data model, and hierarchical data model. Okay, so relational, we mainly throughout our syllabus, it is mainly based on the relational database. Okay, the, in the relational database, data are actually stored in a form of table. Okay, here actually not we can say the file, it called a table. And object based logical model, here use the example is the entity relationship model, object oriented model, and so on. uh, we can discuss also, one chapter is there, the entity relationship model. Here also we discuss in this chapter or introductory chapter just brief idea about the ER diagram or entity relationship model, and details also we can discuss as a one single chapter. Okay, okay, it's better actually the record based logical model and these things actually we can discuss. These are actually takes some time. So it will be better we can this continue in our next class. So if there is any question or confusion or any query, please tell me. Is there any question?
Sir, no questions, sir.
Okay,
Actually.
just a minute. Okay, just at a glance, actually, I want to take the roll call. Just how many students here? 54 students are there. Okay, so all of you, please give your attendance. Just 1 minute. Roll number 127,
Present, sir.
128, 128,
Present, sir.
128,
Present, sir.
129,
Yes, sir.
130, 130,
Present, sir.
131, 133,
Present, sir.
100, 134, 135,
Sir, 132.
Yes, sir. Yes, sir. Yes, sir.
130, 135.
Yes, sir.
Those actually left. Please wait after
No,
complete
sir,
the
अभी 2
even
नहीं,
tell.
sir. 132.
132.
135
हाँ,
present, sir.
Oh, sorry. You are here. Okay.
हाँ, sir.
One actually, your portion is highlighted. For that, I normally think actually it is a not. Sorry, extremely. Okay. Have you
134,
present
sir.
in yesterday class?
Yes, sir.
Isaac?
Yes, sir. Yes, sir.
Okay.
So 134, sir.
134.
Yes, sir.
134 present.
Yes, sir.
135.
Yes, sir.
136.
Present, sir.
137. 137. 138.
Yes, sir.
139.
Present, sir.
140.
Present, sir.
141. 141. 142.
Present.
140. 142.
Present, sir.
142.
Present, sir.
142.
Present, sir.
Okay. Adonna will present in our last class, but
No,
here it
sir.
shows absent. Okay.
No, sir. I was
Okay,
absent.
fine. Okay, thank you. 143,
Present, sir.
144,
Present, sir.
145,
Yes, sir. Present,
146,
sir. Present.
147, 147, 148,
Present, sir.
149,
Present, sir.
151,
Present, sir.
152,
Present, sir.
153,
Present, sir.
154,
Present, sir.
155, 156, 156, 157,
Present, sir.
158,
Present, sir.
159,
Present, sir.
160,
Present, sir.
161,
Present, sir.
162,
Yes, sir.
163,
Yes, sir.
164,
Yes, sir.
165,
Yes, sir.
167. Oh, sorry, 166. 166. 167,
Present, sir.
168,
Yes, sir.
169,
Present, sir.
170,
Present, sir.
171,
Present, sir.
172.
Present, sir.
173,
Yes, sir.
174,
Yes, sir.
175,
Yes, sir.
176,
Yes, sir.
177, 178,
Present, sir.
179, 179, 180,
180 present, sir.
181, 181, 182,
182
Sir,
present, sir.
179.
183,
Yes, sir.
184,
Yes, sir.
185,
10, sir.
186,
Present, sir.
187, 188, 188, 18 by 06,
Present,
18
sir.
by 06,
Present, sir.
18 by 34, 34, 38, 18 by 38, 43, 43, 95, 18 by
Yes, sir.
95.
Yes, sir.
Okay.
Sir, 179.
179.
Yes,
Sir,
sir.
so 133, sir.
179. Okay.
Sir,
Please pardon me.
133. 133.
133.
So yesterday also I gave at the end, sir. Sir, 166.
But you are present.
Yes, sir. Yesterday I gave at the end, sir.
130. Please.
So 133.
Please.
133.
133. I already give
Okay,
attendance.
sir.
Anybody else?
Sir, 156 Sudev Thali.
156.
Yes, sir.
Okay. 156. Then next.
Hello, sir.
166.
Hello, sir.
166.
6.
166. Your
Yes, sir.
name?
Nandan.
Your name?
Nandan.
I already given. Anybody else?
Sir, 178. I was present
Sir,
in last class.
128.
178.
Sir,
It's okay. Anybody
last
else?
class.
Sir,
Sir, previous class.
Sir, 175, sir. I was present yesterday's class.
Yesterday you were
Sir,
present.
128.
So why
Yes,
not
sir.
give your attendance?
Microphone fault, sir.
Microphone fault. Okay.
Sir, mine
Okay,
too,
but-
sir. 156 Thali. Also, it's a problem with my mic, sir.
No. In yesterday class you forget about. Right now actually you can tell me the today class. One roll number 1.
156. It's given for today, sir, but I had my mic problem last day, sir. Yeah.
Don't tell these things.
Actually, sir, my Windows wasn't working properly. I had some problem in, external microphone driver, so I updated today. Some problem was there, sir. Sorry.
अच्छा ठीक है अभी ठीक हो गया मीन्स तो नेक्स्ट टाइम में कोई प्रॉब्लम नहीं होगा ओके थैंक यू ऑल ऑफ यू
স্যার আরেকটা 8034 স্যার 18 সিএস বলছে মাইক কাজ করছে
অ্যাটেন্ডেন্স 834
18 স্যার 18 ব্যাচ
18 बैच रोल नंबर
34
34 you want to say regarding today না
আমাকে বলছে যে মাইকটা কাজ করছে না হ্যাঁ স্যার
তুমি কি আগের দিনে প্রেজেন্ট ছিলে
না স্যার আমার না এটা স্যার
your roll number
না আমি তো সিআর স্যার 132
ও আচ্ছা তুমি ঠিক আছে আচ্ছা মানে 18/34 এর মাইক কাজ করছে না
হ্যাঁ স্যার এইজন্য অ্যাটেন্ডেন্স গুলো দিতে পারেনি
আচ্ছা ওকে I think stop end our class